b equals 0. Then here by taking the moments of all the forces about b equals 0, that give us here Ra into 6. The distance is 6 meter from A to B. Then B to C is 2 meter. Here this load is 3 kilonewton. Then Ra into 6, that is clockwise. Here there is a dummy moment we have applied, that is in anti-clockwise direction. Then moment 2 to 3, that is also clockwise. 3 into 2, that one is 6. Then this equals 0. Therefore Ra equals, that is Ra equals m by 6 minus 1. This one is the reaction at the support support A. Then go to calculate the total strain energy. To calculate the total strain energy, here there are two portions. One is portion origin limit m ei. Here if you consider the first portion A to B, here if you consider a section at a distance of x from A, this one is x at a distance of A. Here if you consider the left portion, there are two forces, one is Ra and one is m, and the origin is A. The limits of integration, x is the variable, it varies from 0 at A and 6 meter at B, hence the limits are 0 to 6. M is Ra into x, that is sagging bending moment minus this dummy moment. Then this equals here m by 6 minus 1 into x minus m. Then ei is constant throughout, that is, then in the second portion in between C and B or B and C, here if you consider a section at a distance of x from C, x is the variable, C is the origin. Here the forces on the right side of the section line, there is only one force. Then x varies from 0 at C and it is maximum at B. The limits are 0 to 2. The moment is 3 into x, that one is hogging, that one is minus 3x. Then flexural rigidity is constant, that is yeah. Now the total strain energy is given by m square dx divided by 2ei over the entire length. Then here the first portion, the limits are 0 to 6. M is bending moment is m by 6 minus 1 into x minus m whole square. This one is the bending moment in this portion divided by 2ei, plus for the second portion the limits are 0 to 2, that is minus 3x whole square dx divided by 2ei. Then here you know that by the theorem, that is Castiglino's theorem, by the Castiglino's first theorem, if you partially differentiate this with respect to the applied force or moment, you will get the deflection or slope at that point. Here we have applied a moment. Moment causes the rotation. Hence, we have applied the moment at A. Then the slope at A is given by partially differentiate this total strain energy. That is, here the partial differentiation of this term, that is 1 over 6 2ei, that is integration within the limits 0 to 6. Then this term here x square is 2 m by 6 minus 1 x minus m. Then the differential coefficient of this one, that is here differentiation of m by 6 is 1 by 6 x, differentiation of minus x is 0, then differentiation of minus m is 1, then this one is dx divided by 2ei we have already written, plus integration of this term, integration of differentiation of constant term is partially differentiate this with respect to m, that one is constant, this term is 0, therefore theta a equals, then this one here substitute, before going to calculate the slope, substitute the value of m equals 0, substitute the value of m equals 0, that is theta a equals, then 0 to 6 1 over 2 ei, then in the bracket 2 to get cancel, this one 2 to get cancel, 1 over ei, m is 0 by 6 minus 1 into x minus 0, this one is x by 6 minus 1 into dx. Then if you simplify this, here this term is minus x, that is 0 to 6 1 over ei, here minus 1 into x minus x, then the remaining terms are 0, this one is x by 6 minus 1 dx. Then if we integrate this, that is 1 over ei integration of this term, that is 0 to 6, here this one is minus x square by 6, this one is plus 1 dx. If we integrate that, we will get the integration of this, that is minus 1 over ei minus x cube divided by 6 into 3 plus this one is minus into minus plus x square by 2 by substituting the limits, that is here this one is 1 over ei x to the power of 3, 6 to the power of 3 is 216, this one is minus 12 plus this one is 6 ja 36 by 2, that is 18, then theta a equals, that is 18 minus 12, that is 6 over ai. This is the solution for the slope at a for this problem. Okay, we'll continue in the next video.